Welcome to the session 6 and the last session of this topic. The compressed air here. There is a variety of that is the viscosity of air is very low and hence the flow velocities in pneumatic system can be very high, which can lead to significant flow dependent pressure drops between air receiver and the air load. This which necessitates the local pressure control. Here and also you can observe from the figure there are essentially three methods of local pressures control. In all the three methods of pressure regulator is employed. In the first method, the pressure regulator simply restricts the airflow to the load. It has two ports in this case and requires some minimum flow to separate. If used with a dead end load which draws no air, the pressure will rise the main manifold pressure. Such regulators in which air must pass through the load are called non-relieving regulators. So local pressure regulators in that first method, that is pressure regulator simply restricts the airflow. So it has two ports and requires some minimum flow to separate or operate. So which utilize, if suppose if they use dead end load which draws no air, the pressure will rise to the main manifold pressure. Hence these regulators regulators are called non-relieving regulators. In the second method, the regulator vents air to the atmosphere without passing through the load. So without passing through the load, air directly passes to the vent that you can observe in the figure at the center area. The air without passing through the load, it enters into the vent. This type of regulators has three ports, one for supply, one for receiver, the other for the vent, and hence it is called relieving regulators. In the third method, the load is quite large and flow requirements are beyond the capacity of your ordinary inline regulators. Hence here pressure control loop comprising of pressure transducer, electronic controllers and a separate vent valves are used. In this method also be used if the pressure regulating valves cannot be maintained locally at the point wherein pressure has to be controlled. The last one here is the distribution of compressed air. In this, distribution of compressed air, this is one piping layout. In a pneumatic system, the various end devices are connected to the air receiver through the pipes. So here there are two methods, one is manifold distribution, the other one is ring distribution. In certain cases, the air supply is installed as a fixed service which can be used later for further or future devices similar to electrical points. That is, whenever the supply is there, it can be stored and it can be utilized whenever it is needed, unlike in electrical points. Generally, the distribution system is arranged as a manifold type or a ring type that you can observe from the figure with a planned placing of isolation. Valves a ring distribution has the advantage that parts of the ring can be isolated for maintenance. Modifications are repaired without affecting the rest of the system. Some of the textbooks I have referred here for fluid power with applications, say Pearson edition, oil hydraulics, Tata McGraw-Hill, Mazumdar, and also the reference textbooks like FESI2, H.D. Ramachandra, in the other textbooks as per the syllabus. I have highlighted certain multiple choice questions here, that is along with the answers. In conventional valves, which component is used to move the spool? So one is torque motor, definitely not. Mechanical servo valve, of course, since it is conventional valves and used to move the spool. So solenoid and all the above. Yes, sir, definitely the answer is solenoid, which is used to move the spool. What does the servo mean in servo valve system? So servo means here definitely the first two answers are wrong, because it cannot receive a feedback, but the desired output can be obtained, not definitely. And it cannot receive, because the servo mechanism is nothing but servo means it is receiving, that is it can receive a feedback and the desired output can be obtained. This is another question here. So another question, in conventional valves which component is used to move the spool? Definitely the solenoid. I have already given in the earlier one similar question. So of course the answer is same, the question is in different manner. Advantage of DC solenoid coils, that is DC solenoid coils have constant level of current. How is tilting action possible in trucks for unloading the gravel material using hydraulic power? Definitely the answer is A, because tilting action is possible if oil flows or high pressure into the cylinder. Tilting action is possible if air flow at the low pressure into the cylinder. That is either in pneumatics or hydraulics. Hydraulic system is more precise than pneumatic system, because pneumatic system is an open system, suits for smaller applications. So definitely the answer is B. And in which circuit relay of low voltage and low current is used to make open or close contact? That is definitely high voltage and high current. Because relays, that is electromagnetic electromechanical system here we are using, definitely the high voltage and high current circuit. The next question here is electro-pneumatic circuits, or here we are using spool is shifted by electromotive force, and electromechanical relays more popular than solid state relays. That is they are reliable, less, the cost is minimum or least. In which system the spool of the servo valve is operated by a torque motor? Definitely the electro-hydraulic servo mechanism. What does servo mean in servo valve system? That is, it means it is receiving the feedback. Yeah, certain questions I have highlighted here are from the previous question papers. That is, explain the motion control diagrams for a 2-cylinder circuit given in 2015. Write a note on relays used in electro-pneumatic control. So a commonly used question here. Sketch and explain the non-receiving types of pressure regulators, of course. Write a note on air filters and air dryers. What is lubricator and why air is mixed with oil? Explain the different methods of distribution of compressed air.